So I've split the big end in two pieces. If you're doing this, be very careful of this material because it's so gummy and toffee like, as I've mentioned before. It's very hard to keep the saw cut dead straight, and I've used a coping saw with an extremely thin blade because there's not much machine allowance over this total dimension. So next thing is I need to machine the bottom side flat to a depth of 1/4 of an inch. That's a 1/2 inch diameter feature there, so that'll be 1/4 of an inch, so that's what I'll be heading for. So over to the mill, I've already set it up, it's inverted, and I've set this face vertical, so hopefully this face will be at right angles to the axis, but we'll sharp find out. So over to the mill. This should be the final cut down to 1/4 inch thickness, but we'll double check when I've finished. In case you're wondering what this is, adjustable parallel has been set to exactly the same width as the part being machined, so that when the vice is tightened the jaws close in a parallel fashion. Without it, the jaws would definitely cant to one side and the part wouldn't be held so securely. taking a light skim off this. This is the other half of the bottom half. You can see I've already cleaned up the bottom face of that. That's exactly 1/4 inch thick. I'll do the same with this part. So that's the big end split into 2 parts. Now, just looking at the diagram, the boss of the feature here is 1/2 inch diameter, so these 2 halves must be 1/4 inch thick, which they are. I've machined the bottom face flat on both parts. Next job, of course, will be drilling the 2 clearance holes for the bolts to pass through. I've got to spot face the bottom surface as well, so this is all fairly straightforward stuff. I've marked the, I don't know if you can see that, before I split the bottom end. I put some little marks on so that I can get the orientation right when they're bolted together. Shouldn't be a problem because I've got a lot of confidence in my DRO. I'll try it around the other side just for a laugh, and I suspect it'll be absolutely fine anyway. A little bit about castings. Now, if you're making the same engine as I am, carefully check your alignment of your castings between the top and bottom halves. They're cast in two halves. That's the split line. And check for alignment between top and bottom parts. This end is not too bad, that way around, not too bad that way. But when we get to the small end, oh dear, is where it all goes terribly wrong. I don't know if you can make out the offset there. This is totally unacceptable. This shouldn't have left the foundry, it should have been remelted. What's happened is that the 2 halves, when they're put together, normally there are pins that hold the casting sandboxes together so that you get correct alignment, but one of these has shifted at some stage before they've poured the metal, and this is the result. Now, normally, if you've got a large machining allowance, you can overcome this. You just machine away all the misalignment until you get down to shiny metal all round. But with this particular casting, machining allowance down the bottom isn't too bad. There's plenty on the tapered section, but here is almost none at all. Now that's supposed to be 0.3438, which is near as damn it that. Now I can't make that out, but that's almost close to size before machining. So there's no way I could machine that and end up with the required size there. No way. I just about got away with the first one. You can still see some marks on the top here. That's the original casting material, and this was 8 thou oversized when I finished as well. So quality control isn't up to spec wherever these are made. I'm not very happy. This is going back. I can't do anything with that. If I tried to machine it, I'd end up with the boss way undersized, and I'm not having that. So just a little pointer in case you're not just this engine, any engine that involves castings, it's worthwhile checking the alignment of the top and bottom halves along the split line. So as I say, next thing, just drill those holes. I don't think I'll bother filming it because it's fairly straightforward. It's just edge finding to find the center of each part, and then coming across on the center line half this distance, which is 28,125, and Bob's your uncle. And I'll flip that part over and spot face there and there. Okay, off we go. Well, that worked quite well. My good old trusty DRO was spot on. Everything went together as it should. Next operation, of course, is the biggie. I've got to drill the hole here, drill and ream for the crank pin. So I'll set that up in the lathe, find a center line across this face, and then put a pin in here, zero the x-axis and the DRO, and then I can move across, and hopefully it'll be bang on that split line between the two parts, and then pilot drill and ream, and we haven't got much to do now. We've just got to turn this feature on the front, boss, whatever you call it. There's no there's not much information regarding this this elevation here, but I've done a sketch. I'll zoom out a bit so I'll get the whole thing in of what I'll be using on my particular model. The overall width 3/8.375, that's given on the drawing, but the I've used the size of the bolt and nut heads, you know, the cross corner dimension, to give me some idea of what will aesthetically look alright. And I've come up with these figures: 1/4 inch for the final width there, and then this feature here will be the difference, 16th, 1/4, 3/8, 16th of an inch, and that's that. We'll see how it goes. Well, that went well, quite pleased with that. Next final step is to machine these sides. The overall width is a little bit more than it should be. It should be 3/8, and as I said before, I've got my drawing ready. What I'll do is I'll make a mandrel for this and super glue it on, and I've got a cunning plan to get this diameter, this 1/2 inch diameter, spot on, because it's a curved surface, and trying to measure it with calipers and that is going to be a bit hit and miss. So it's over to the lathe next. Nearly there, not much left. Again, a lot of metal removed. The drilling and reaming this was a bit scary because I know it's very grabby material, but this is well clamped, and I had the fine feed on the quill engaged, and took it down very, very, very carefully, and no drama. Okay, off to the lathe. So here we go. I've decided to make an arbor or mandrel for this last part of the machining. I've turned this bit of brass down to 1/2 inch diameter exactly, which is the final size of the feature as required in the drawing. I've got my tool just set very close to the blued area. I'm going to flash up the lathe and just touch off, so that when the tool is fed into the work, I'll just be coming across a few thou at a time, but I'll just wind into 0 once I've set it on the DRO, and then I'll come across and then just lightly touch off on this side of the tool against the face of the big end, and that's my other 0. So I'll be working across the way, a few thou at a time, until I reach my calculated 62.5. 62.5 thou from the face, that position, and wind in that way to 0 on the DRO each time, and then I know at the end of the operation that the feature will be exactly the right diameter. Not sure about this distance in from the face. I'll see how it goes, see how it looks, because the casting's basically crap anyway. Okay, I'll flash up the lathe and do some machining. Just need to touch off. There, 0 the y-axis. For a minute. This part is turned down at a close fit to the big end, and the length there is just a few thou less than the width. This is now to size. This is 375 wide. So get that on. A little clamping bolt. That little spacer that you see there, little brass spacer, it's just got a clearance hole in for the 4mm screw. So I can guarantee when we start the lathe again, this part will be wobbling around eccentrically. Right, nice and secure. If I need to go in, I'll just do this. I'll find a part that's nice and wide. I'll just go in and just touch the side. There, 0 the x-axis. So I've got 2 coordinates now. Okay, the other thing to note, I've got the tool set at an angle because this part, the small end, is wider than the big end, and I didn't want the small end whacking the tool. I'm not going to retract the cross slide that far anyway, but just to be on the safe side. And a bit closer. Okay, we'll spin it up. There's no weight involved in this, so I'm not worried about out of balance forces when I'm up to speed. It'll run about 800 probably. And down to 0. touching anything at the moment, so I'll just come in until there we go. And so on and so forth. Right, that's one side done. It's down to 62.5 thou. Could have taken a wee bit more off. It's still got a bit of rough casting there. I'll flip it around, do the other side and see how it looks aesthetically, and I might adjust the thickness accordingly. I'll get back to you on that. So there we have it, all done. Give it an 8 out of 10. I'll give it a 9 if I take my glasses off. There's still some remnants of the original casting surface on the back corners here. Not a lot I can do about that. I could have kept on machining these faces until the corners were sharp, but then it would have been awful thin on this part. So I've stopped it there. Those two are going to be at the back anyway, so that's what I'm going to do. I need to obviously do it all again with the other casting when I eventually get a replacement. Oh, by the way, if you're going to use super glue to fix this to a mandrel, you'll need some heat to break the bond when you want to remove it. So I strongly suggest you take it outside, preferably on a windy day. Wear a face mask before you even light up the torch. I wouldn't want to breathe the fumes from that process. The clue's in the name, of course, cyanoacrylate. So on that gloomy note, I'll bid you farewell. Thanks to everyone who's subscribed. Thanks for your very positive comments. It's what keeps me going with this little new venture of mine. And I'll see you in the next video. Until then, take care and bye for now.